Hello everyone, you're watching Claude, and in this video I'm doing something that I hope will be very resourceful and helpful to you guys. I'm going to use Minecraft to help explain logic gates, which is a super important topic in real world computer science and also for redstone contraptions in this game. This means that this video should be helpful with A, explaining the concept and functions of logic gates for those who have taken computer science in higher level education like myself and may be struggling to understand them, and B, showing how to construct and use these logic gates in Minecraft for redstone engineering and creating machines at any level of complexity. I've decided to use Minecraft to help me explain these logic gates, as I'm sure that everyone watching this video has either played, seen, or at least just knows about Minecraft, so it'll be easier for them to understand and grasp the concept in a more familiar way. Even if you don't understand how redstone works, that's fine, as I'm only really using it to give a visual aid to my explanations. However, you will need to know the very basics if you're watching this video solely to learn how to make these systems in Minecraft instead of from an educational point of view. And by this I mean the very basics of redstone, like what it is and how it works, not the more complex principles and stuff. Once I'm finished explaining the logic gates, I'll also give an example of how they can be used in more complex systems, so stick around for that as it can also help increase your understanding. Now then, let's get started with a basic explanation of what logic gates are. Logic gates are necessary components of computers in real life and contraptions in Minecraft, and neither can exist without them. In case you're unfamiliar with them, logic gates are tiny computer components that do a certain task, and can be joined together to form logic circuits, which are what allow the computer to function. There are a wide range of logic circuits and each one does a different thing. The ones I'll be showing you today are the NOT, AND, OR, NAND, NOR, and XOR gates, as these happen to be the ones that are covered in my computer science syllabus. Logic gates function in this way. They take a certain number of inputs, complete a task on them, and then produce an output that depends on what you input to them. There can be any number of inputs and outputs, but the gates we are looking at today only feature 2 inputs at most. Computers can only understand binary, which is a computer language consisting of only ones and zeros, in which the ones basically mean on or true, and the zeros basically mean off or false. These numbers act as the inputs for the logic gates. In Minecraft, our input is a redstone signal of some sort, and in this case we'll be using a lever to function as our input, as you can see here. So when the lever is flicked off or facing upwards, that means it's off or giving an input of 0. When we switch it on, however, it will give our input as 1 or on. As you can see here, the redstone signal is now lit up, meaning that the input is on. These redstone lamps will be our output, and so if we connect it to the circuit, as you can see here, when it's lit up the output will be 1, and if we turn it off, this will be an output of 0. So lit up is an output of 1, and turned off is an output of 0. Now each gate functions differently, so even with the same lever combination of inputs on each gate, the output will vary. Let's take a look at the NOT gate first, which is the simplest gate as it only has 1 input. In this gate, your output will simply be the inverse of your input, so as you can see here, the input is 0 or off, and the output is 1 or on. This is true the other way round, as if we put an input of 1, our output will become 0. Now here's a handy tip to remember the name of this gate. Your input is not your output, so if you can see here, as I've shown you, an input of 1 will be an output of 0, so it's not your output, it's the opposite. Now this is how you can make the gate as I've shown here. You need a redstone torch like this, or you could build it in this way. Both of these function in the exact same way, so they'll both work. Now you just have to be careful when you're building this gate with the redstone torches, as you have to make it in either way of these ways shown here. You can't make it like this, as when you switch it like this, as you can see, it affects the redstone torch. So if you switch it on, it turns this redstone torch off, which is what makes it function as a NOT gate. As if you have it going directly into the redstone torch like this, changing your thing will not change the output, and so this does not function as any sort of gate. Moving on to the next gate, which is the AND gate, and this is now slightly more complex as what we've seen before, as now there is 2 inputs. This means that there are 4 possible inputs that we can have, such as 0, 0, 1, 0, 0, 1, and 1, 1, which means there is a lot more stuff you have to factor in. This gate, as the name suggests, requires you to put one input and the other to get an output. Otherwise, the output will always be 0. It doesn't matter how you put the inputs, if one's on and the other's off, if they're both off, if the other one's on and the other one's off, all of it won't give an output unless both of them are on. And this is how you have to build the gate. I'm not aware of any other ways you can build the gate like the NOT gate. I think this is just the only way you can build it, so you can take a second to look at this and see how it's made in case you want to make it in Minecraft. Moving on, the next gate is the OR gate, and this gate requires you to have one input or the other to have it switched on. So as you can see here, with both of them switched to 0, the output will be 0. If I switch one on, the input will be 1. If I switch one on, the input will be 1. And if I switch them both on, the input will always be 1. So this output requires you to have any input and the output will be 1. And this is how you can build the gate as I'm showing you now. It's probably one of the most easy gates to construct, and the only reason I've got these repeaters here, as you can see here, when I switch this on, this signal also doesn't get switched on. I just did this so it's easier to show, and also that could possibly cause some issues if you're trying to put this gate in another bigger mechanism. So if I replace these and just put redstone here, as you can see, it switches the whole thing on, which isn't something we want with this gate. In this example here, it's okay, it doesn't affect it, but yeah, it could cause problems further down the line. Now this is where the gates start to get slightly more complicated. This is the NAND gate, which basically means the not AND gate. So it's a combination of two gates. So this gate is basically the opposite of the AND gate. So as you saw with the AND gate, it would only give an output if both of the inputs were set to 1. In this case, it's exactly the opposite of that. It will only give an output as long as both of the inputs are not switched to 1. So as you can see here, both of the inputs are off and it gives an output of 1. If I switch one on, the output's still 1. If I switch the other one on, the output's still 1. But if I switch them both on, the output switches off. So this is how you can build this gate. It's an AND gate as I've shown before, and then just a NOT gate. So it's quite simple to build this. Moving on is the NOR gate, which is a combination of the NOT gate and the OR gate. So very similar to the AND gate in the way that it's a combination of two gates. So just like the NAND gate, this is the exact opposite of the OR gate. As with the OR gate, if you put any input, your output would be 1. In this case, if you put any input, your output will be off. So as you can see here, there's no input currently, everything is switched off and the light is on, meaning that there's an output of 1. The moment we switch any lever on, the light switches off and we don't get an output. And so this remains true with switching on any number of things. As long as there is just an input of any kind, it will switch off. Just like the opposite of the OR gate, which is exactly what it is. Now this gate is slightly more complex to build, and this is the XOR gate, which means the exclusive OR gate. You could also pronounce this as the XOR gate, and it's also known as the EOR or the EXOR gate. So this gate is not like the others, as whilst it has a combination of a couple of gates, it is slightly different in the fact it also has some stuff such as a piston blocking signal system. However, I am going to go through this bit by bit, and so then it'll be much easier to understand. So this gate functions in this way. When you have both of the inputs off, the output will be 0. If you switch one on, the output will be 1. If you switch another input on, the output will still be 1. However, if you switch both the inputs on, the output will switch off. And this is why it's called the exclusive OR gate, because it can only be exclusively one input to give you an output. Now I'm going to go through and show you how I've made this gate. Now looking at the first part, it's very simple. You just switch on a signal and this goes through the repeater, as I've put these repeaters before so the signals don't interfere like I showed you before in the OR gate, so this I've already covered. And the signal just goes all the way straight to the lamp and lighting it on. Now this is the exact same case. If I just switch it to the other one, the signal just goes round here and gets blocked by the repeater so it doesn't light up this, and so it goes straight to the light. And also you may have noticed there is a secondary trail out of either of these. So there's another trail out of the left one that goes round here and a trail out of the right one that goes over here. Now this is an AND gate as I've shown you before, and as you hopefully remember, this means that you will need both the inputs to be switched on to give an output. So if you switch on this one, you can see the trail goes down here and this glass just allows it to pass under this signal without interfering with it. I've got a repeater down there to extend the signal, otherwise it wouldn't be able to make it all the way to here. And this goes to here and switches off this redstone torch. The same happens with the other one. If I switch it on, it's just a bit of a more direct route. It just goes straight and switches this one off. Now, if we switch them both on at the same time, a lot of stuff happens. But so let's just go through this step by step as well. So if we switch them both on, the AND gate comes into function and gives an output here, as both of these torches have now been switched off and it gives an output. This output goes to this piston, and this piston pushes a block across, which blocks this signal, has signal here, it gets blocked off down here, and then the thing doesn't get lit up. The lamp is off, there is no output. Right then, so that's all the gates I'll be covering in this video. These gates are very important for making more complex machines later on, as you can see some of the ones I've made here in my redstone testing world. Most of these machines would not be possible without using these gates. I'll now show you a very simple and common example of one of these gates in a basic contraption so you can get what I mean. What we have here is a simple piston door, one of the most common and easiest contraptions to make in this game. It functions in this way. A player or item stands on the pressure plate, emitting a redstone signal that goes to the pistons and disables them, opening the door. As soon as this player walks through the door, they step off the pressure plate and stop the signal to the pistons, and so the door closes behind them. Simple. However, there is one problem. I've built a secondary door here so you can see what I mean, and I've left the redstone exposed like this so you can easily see how it works. So if you started to build it like I've done here, you'll notice that the door is not closed by default. And if you try and step on the pressure plate, the door will close. This is the exact opposite of what we wanted. So what we can do instead to combat this problem is build a NOT gate. So building a simple NOT gate like this means that the door is now automatically closed, and when we try to step on the pressure plate, the door will open and let us through. When nobody is standing on the pressure plate, the input is 0, and due to the NOT gate, this means that the output is then 1. This means that the pistons are powered and become closed. When we stand on the pressure plate, the input becomes 1, and the NOT gate changes the input to 0, and so the pistons become unpowered and we can walk through. I hope that with this example you can now understand how logic gates are essential parts for circuits, not just in Minecraft, but in real life computers too. If you found this video helpful, why don't you give it a like and recommend it to others? And whilst you're at it, why not subscribe to my channel? I make a whole range of videos, from tutorials and stuff like this to travel vlogs and gaming videos. If you want me to make more informative stuff like this in the future, whether it be on educational, school-related stuff or tutorials for more of the basics of Redstone or maybe even the more complex stuff, let me know in the comments down below. These types of videos are easy and fun for me to make, so I'm definitely up for making more of them in the future, and I'm sure there are many more things I can help you guys with. Now, before you go, there's one more thing I must add. If you guys are fed up with my inconsistent upload schedule, I'm really sorry guys, I'm trying my best here, why don't you check out another channel in the meantime of waiting between videos? And if you need help finding something entertaining, then look no further than Jackrants, an emerging new channel that looks to have a very promising future. This channel houses funny and well-edited videos ranting about anything and everything, from the FIFA games to wannabe rappers. It has a much more frequent upload schedule than mine, as although it only started very recently at around 2 weeks ago, he's been able to make 6 videos and tries to stick to an upload schedule of a video every 2 days, which is insane compared to my schedule of a video each month. So if you want some laughs in such a bleak time, I would highly recommend checking it out, and I've put a link in the description of this video as well. Be warned though, this channel has some language and controversial opinions, although I do agree with the majority of them. But for now, that's all from me. I look forward to seeing you all soon, and you should remember to look after your health in these unusual times. Take care and goodbye.